Hello, calculus fans. We're going to talk about moments and centers of mass. So our goal is, given a thin plate of any shape, we want to find the point where the shape balances horizontally. So let's suppose we have a rod. So this is a long, thin stick of negligible mass, and it has masses m1 and m2 on opposite sides of a fulcrum. And they'll be at distances d1 and d2 away from the fulcrum. So a fulcrum is a point at which things can tip one direction or another. Here's a picture. So you see that we have two masses and they are a certain distance away from the fulcrum. In this picture, d2 is a little bit bigger than d1. So the question is, when does this balance? So Archimedes discovered the fact that the rod will balance if and only if m1 times d1 is equal to m2 times d2. And in physics, we call this the law of the lever. So now let's put everything on a coordinate axis system. So we'll put the mass m1 at x1 and the mass m2 at x2. So this coordinate system, really, we're just going to have an x coordinate for now. And let's suppose that the center of mass is located at x bar. So here's the new situation. So the distances are actually the same, but now we have these masses and we're going to place them on the coordinate system at x1 and x2. X bar is this balancing point, the question being, where do we place the fulcrum so that everything balances? So according to the law of the lever, m1 times x bar minus x1, it has to equal m2 times x2 minus x bar. And what we're going to do is we're going to solve for x bar. This equation is linear in x bar, so it should be easy to solve. So if we distribute things and move things around, we get m1 x bar plus m2 x bar is equal to m1 x1 plus m2 x2. And we solve for x bar, we get m1 x1 plus m2 x2 divided by m1 plus m2. The numbers m1 x1 and m2 x2, these are going to be called the moments of the masses m1 and m2 with respect to the origin. So the equation tells us that to find the center of mass, x bar, we add the moments and divide by the total mass. So moments divided by mass. Now in general, if we have a system of n particles with masses m1 through m sub n located at points x1 through xn along the x-axis, you can similarly show that the center of mass of this system is located at the sum of the moments divided by the sum of the masses. So I think instead of the sum of the masses down here, we'll just write a little m, indicating that we're talking about the total mass of the system. Now this sum of the moments is called the moment of the system about the origin. It's worth noting that using the word moment is a technical term in physics, and it is used in this sort of context. Next thing we want to do is consider a system of n particles with masses m1 through mn, and now they are located in two-dimensional space in the xy plane. So we give the coordinates of the points and we give the masses. Now there's an analogous calculation where we can define the moment of the system, but now it's about a particular axis. So the moment of the system about the axis is the sum of the moments where we multiply the masses times the x-coordinates. The moment of the system about the x-axis is where we sum the masses times the y-coordinates. And so now we can give formulas for the coordinates of the center of mass. So x bar is equal to the moment about the y-axis divided by the mass, and y bar is the total of the moments about the x-axis divided by the mass. And as before, m in the denominator there is just the total mass of the particles. Okay, that's all for now.